Hello, welcome back, and we're about to talk to Vlad De Turckheim. So, based in France, we've got Vlad, who has a very secure history and has worked as a professional security auditor, and he gives talks and training to software engineers to teach them about application security. He now works at Screen, which I hope I've said correctly. He builds secure web applications. He's one of the most active members of the Node.js security working group, where he handles the security of Node.js and its ecosystem. So today he's going to be talking about a curious API that was added to Node this year. I give you Vlad De Turckheim and async local storage usage and best practices.
Hi. Thanks so much for
Hi.
having me. Let's go. So, can you see my slides yet? Awesome. So thank you and welcome to my talk about async local storage in Node.js. Quickly, but I've been introduced. I'm Vladimir De Turckheim. I'm the lead customer engineer at Screen. We secure web applications. So if you've got Node.js in production, you probably want to check what we do. Also, for those who know me, I'm usually wearing a beard. And because this year I'm taking part in Movember and trying to raise money, to raise awareness regarding masculine health and mental health, I decided to shave and grow a mustache this month. And if you want to support me for Movember, please click on my link and donate for that. I would actually really appreciate that. Thanks so much. Let's talk about thread context. And most people are about to ask threads. It was supposed to be a Node.js talk, but we will still talk a bit about that. So let's take some code. It will be a presentation that will be heavy on code. Here we've got a log function defined from line 1 to 3. And as you can see, the first argument taken by this log function is a request object, an HTTP request object. And on line 2, when we log something, we do console.log rec.id, and then we log the rest of the arguments. This function is made to be called in a middleware, so every example in this code are made with Express. I love other frameworks, but that's what I had ready. And we create a middleware that takes request, response, and next as parameters. And each time we want to call the logging function, we need to pass the request object as first parameter. And yes, we need to pass it, and we got used to pass rec enclosures or as arguments everywhere in our code. Like that for decade, at least one, with Node.js. And as a Node.js engineer, we all got used to doing that. Of course, someone could argue, hey, you could only pass part of it. So let's say I just want to pass the ID to my log function. I would make my log function take a first argument as an ID and then log. But then maybe you want to log other traits of the request later in the life cycle of your app. Let's say you want to also log the method and to update the signature of the function and the signatures of all functions calling it. So it quickly becomes a mess. And that's an easy case because there is only one layer of call. So in my example, we've got the controller, the Express middleware, calling the log function. But what if you are calling methods through other abstraction layers, like if you have services or data abstraction layers? You need to pass something about the current HTTP request all the way down to the last line of code in the layers of your application. And that's a mess. And why do we have to do that? Do we really have to do that? And how do they do that in other languages, in other technologies that are not Node.js? Well, in a threaded world, like in PHP, in Java, in Ruby and Go, most of the time, what they do is they create a new thread for new incoming HTTP requests. And a thread store. where they can store something that is linked to this thread, and that's a singleton in this thread. So for instance, in a Java Spring application, if you don't go with asynchronous methods, at any time you can just say, hey, I'm in a thread, what is my current HTTP request? They can do error handling, and they can do calling, and that's basically a big bind function that is bound to the thread. In a single threaded world, there are multiple HTTP requests handled in the same thread. And there is no single truth. It's actually really hard to say this line is executing because of this HTTP request. And I will demonstrate that with an example about exception handling. I've always considered that exception handling in Node.js was weird, and at one point I just accepted it and decided that it was cool, but it's still weird if you take a step back. So we've got two examples of code here on this slide. On the left-hand side, we've got an async function named main that awaits a promise that just resolve and then throw a new error. And then we call it with a rightful catch. And if the error is caught, we can just log down because a successfully caught promise failure returns promise fulfilled. And on the right-hand side, we've got pretty much the same thing. With one exception, there is a process.next tick around the error being thrown. But the way we call main is the same. If I run the first piece of code, I actually get exception logged, my exception, and then it logs down because the line 9 of the code on the left-hand side is executed successfully. On the other hand, if I run the code on the right-hand side, well, I just get an exception and the process crashes and the console.log down, the line 11 is not executed. And that's what I mean when I say error handling in Node.js is weird, because depending on how you call things, whether you are in an asynchronous operation, in an async call, in a promise chain, you have different outcomes. And one of them is the process crashes. So the next tick asynchronous operation lost a cause stack. And Node was not able to know why it was running this line of code because the cause stack was lost at the asynchronous operation. So that leads me to the second part of the talk. Why is this piece of code executing? When you look at a line of code in Node.js running, why is it running? So that's why we created async local storages in Node.js. It's an API you can use to create context in asynchronous environments. So async local storage is used to create an asynchronous proof store. Basically, it creates a context for your code and will spread it through the event loop for you. Okay, so it's a pretty straightforward API to use because you just request from the async hook core module, and then you call new on it. So that's what I do on line 3. I call new async local storage and I create a context, and I need to create only one. And then I need to enter the context. I need to start running code within the scope of the context. So that's what I do on line 5. I call context.run. The first argument I pass is what we call the store. It's actually the value that will be available for all calls made within the context. Then I pass a callback function, and everything there will have access to the map that is created when we call context.run. Don't worry, there will be better examples right after, like in this slide. So remember the examples about my logger that gets extremely verbose with a terrible signature? Well, let's fix that. So on line 1, I require async local storage. On line 2, I create a new context. And then I create a log function. And this function only takes arguments to log. And what it does on line 4 is it retrieves the current store. It calls context.getStore. So this might actually return undefined if you're not within a context. So my code is terrible at error handling here, which is a bit ironic, but I wouldn't have enough room on the slide to do things as I wanted them to do. So please don't blame me too much on Twitter. On line 5, we get the request from the store. In work, the store is just an instance of map. And then we can log.id and the rest of the parameters. On line 9 to 15, we have the first middleware. What it does is it creates a store, which is just a new map, and you can use any other value actually. And then, as explained in the previous slide, we call context.run with the store. And what's important is we set request inside the store, and we call next in the callback. And from now on, everything that happens called after this single next call on line 13 will have access to the store, meaning that context.getStore will return the map we created and we pushed the request inside. And now on line 19, we can just call log and it will log the things properly as it was bound to the HTTP request. So no more need to move request around, right? You can always know what is the current request context, which is actually pretty cool because you can make your code less verbose. But logging is just an example. And let's talk again about exception handling. In my case, I've got a first piece of code, first middleware that calls /async and throw an exception in process.nextTick. Then we've got a second middleware /sync that throws an error directly, and then we registered an error middleware to tell Express what to do with our errors. So let's run this code. If I get on /sync, it actually calls error middleware. If I call /async, it crashes the process. Once again, it's a question of stack trace. So actually, Express injects a hidden try-catch around all middlewares. And the reason why in the first case it called the error middleware because there is a try-catch around the callback you pass to the middleware, around the middleware function. It's caught and spread to next. But in the second case, Node is not able to know that the try-catch, the implicit try-catch Express put on line 1 is related to the error thrown on line 3 because of the asynchronous operation on line 2. So let's create a handling error mechanism. So at the first line, I create a function named handle error that takes an error, request, and response as parameters, and it does whatever we want it to do. That's not really important for this demo. But on line 5, from line 5 to 10, I will do something that the Node.js documentation explicitly discourage. But I think it's time with this API we rethink this discouragement. So we're supposed to use on and quote exception on the process level because your application might be in a weird state, an undefined state. However, thanks to AsyncLocalStorage, you have a way to keep a real state for your application and know what is happening. So in my case, register a handler for unquote exception, get the request, the response, and spread it to handle error. Once again, this could return undefined and there might be mistakes in my code, but that's for the idea. And then I just tell Express on line 12 to use an error middleware that's forward to my handle error function. If I call /sync in the previous code, it calls handle error through the error middleware. If I call async, it calls handle error through the unquote exception middleware. That's for the unquote exception event listener. And we have a unified way of handling errors in Node.js under certain circumstances in this situation. Other use cases, well, someone told me about user management, like when a user is identified into the app, they will just set it, and now they don't need to pass the user to the database layer in their code. They can just fetch it from a store and log the operation in the database to that user directly. Monitoring, you can build your own monitoring tool to automatically track, log, and monitor what happens in your app. Having a single database transaction for the HTTP request you just retrieves to your store. If you have other ideas, let me know. Okay, and since I still have 10 solid minutes before the end of the talk, let's spend 5 minutes on seeing how the code looks like for this API in Node.js. So believe it or not, this API is only 72 lines of code or something like that. Okay, yeah, I know. It relies on a lot of fields of Node.js, but actually the AsyncLocalStorage class and its companion Async Hook is very light. Let's track how it works. So here I've got a simple example. I create an instance of AsyncLocalStorage on line 4. I call another method, another way to get into the scope of a storage. That's a synchronous way. That's a way that won't require a callback. That's enter with. I just set the store. And now I start foo bar into my map. That is my store. And if I call process.nextTick, I can log session.getStore.get foo, and it will return bar. In Node.js, everything happens in the context of an asynchronous resources. So there are resources, and at each time you are within the context of one. So in this example, almost all the code happens in the resource of the first scope, of the parent scope that is created by Node.js, the core one. But the line 10 is executing in the resource related to process.nextTick. Okay, that's weirdly theoretical, so let's go with a real example. Hopefully there is a great API in Node.js that has been built by amazing people. That's execution async resource. And for each of these resources, we can actually get an object that will represent the resource. So on line 4, we console.log the current execution async resource. On line 7, within a next tick, we do the same. Without a log, the first object is an empty object, and the second one, object that has been actually linked to the process.nextTick. So each time we've got an asynchronous operation, whether it's a promise, whether it's another kind of asynchronous operation, we've got a resource object created and accessible at any time. So what's next? Let's take our example and go through the code. We've got a new async local storage. Well, it's a dummy constructor. It creates a symbol. We'll use that later, and sets it to not being enabled. Okay. Then we call session.enter with new map. This function is a bit more complex. What it does is, if we are not enabled, it enables the thing, and it pushes the current instance to something named storage list. Let's see later what this is. So it calls storage hook.enable. So storage hook, it's an async hook with just an init hook. So each time there is an asynchronous operation created, this will be called with the parent and the child resource. Okay, so now we set something in the store. We just call getStore. GetStore, it's pretty easy. We call execution async resource, and we ask for the store that is linked to the current resource. Okay, now we call nextTick. As I told you, it means that our init function will be called. So it only uses an init hook, no before, no after, no delete. So what it does is it actually finds the parent resource, which is the current one when you create something, and spread the data to the new resource. That's the propagate method. And the propagate method just takes the store from a resource and spread it to another one. And that's as simple as that. And then when we get into our next tick, well, we are in the new resource, and we call getStore again. And getStore, it just gets the current resource and gets the value of the store attached to this current resource for this instance of async hook. So you can check the source in Node.js core. It's in /lib/asyncHooks.js, and it's pretty straightforward and easy to understand. It's memory safe and pretty fast. I have to highlight that there is currently an API, a PR on Node Core that fixes a memory leak in one of the functions that I have not disclosed in this talk yet. So Brian, don't send me messages immediately to complain. A few best practices and gotchas. That's the last part. This is prod ready. as it is still marked as experimental in Node, but there is an ongoing thread about marking it as experimental. It's coming, it's usable, it's already used in production. And there are actually discussions. There is a stage 0 proposal to bring a similar API directly to ECMAScript. Be careful, there might be things that break it. For instance, if you build queues, you don't have this change of asynchronous resource. Because let's say I just have an array and I push things at the end of the array and I pop things from the beginning of it. I have a queue, and it won't be really possible for Node to really know what you pushed in its context, what you got in each context, if you wrote your own queue yourself. So there is a very handy API in Node.js core named Async Resource. It's also in Async Hooks core module. And what you do is that you can register your own async operation that will actually trigger the call to init each time you are going through that. So please take a look at this API if you have custom things that might break this context when you've got improper asynchronous context. Don't share your instance of AsyncLocalStorage. So if you build a module that uses AsyncLocalStorage under the hood, don't share it outside. You don't want anyone to pollute it. For instance, and you don't want to share the namespace globally. For instance, there is an original module doing that's named Continuation Local Storage, and there has been a fork of that named CLS Hooked. And I'm so mad that the CLS Hooked actually breaks the use of the continuation local storage because they overwrite things on the same places on process. So don't share your instances. The fact that the instances are not globally shared is by design. Don't share them. Okay, best practice might go against the previous one. Create too many async local storages within one app. So my rule of thumb is create one per scope. Create one for your business logic, have one for your monitoring tool, and have one maybe for security layer, especially if you use Screen. But don't create too many of them, because each time there is a new asynchronous operation, each time init is called, we have to loop over the instances of async local storage. Consider the store as immutable if you're using basic types. So if you just put a number, a string, consider the store as immutable and keep the state keep it the same. And for anything else, I know it's discutable. Use a map, and everyone will expect a map, and nobody will have weird optimization path in V8. Use a map for everything else, and don't step on each other's toe by writing on the same entries as your coworkers. Use the run method to get into an async local storage. It's the one that takes a callback, and use enter with only if you need to. So if you're interested in going in depth about the issue raised by callbackless entering, you can check the domain postmortem on nodejs.org. It can lead to weird behaviors that are predictable but needs a really good understanding of what's happening under the hood. So the run one actually scopes the thing and in the callback, so use that. There's another method, exit. If you're not sure that your context will be garbage collected, that there are too many asynchronous tail calls at the end of a request, for instance, use exit to positively leave the store. And last but not least, go for it and provide feedback, please. We are waiting for that. We love feedback. We want it. Thanks so much for your attention. Let's keep in touch. You can email me. You can tweet me. Here is my Movember link again. I will post the slides on Twitter in a couple minutes. So stay tuned. Enjoy the rest of the conference. And thanks so much for your attention.